This is the example video for a quotient of powers. So first problem, we have x cubed all over 3x. Okay, so first I'll take care of my numbers. So I've got an imaginary 1 up top here, and I've got a 3 down bottom. So I've got 1 divided by 3. I can't simplify that. So 1 over 3 will be a part of my solution. And then I have 3 x's up top and 1 down bottom. So to simplify that, I'll use the quotient of powers property. So I'll subtract 1 from 3, and I get x squared. So, since I've taken care of everything, my final answer is 1/3 x squared. Okay, so you can have your answer like this, or you could just throw the x squared in the numerator. Either one is all right. Pause the video if you need more time. Okay, so here we have 3r squared divided by r squared. So 3 in the numerator, and we'll divide 1, which is in the denominator. Okay, coefficient of 1 here for this r squared. So 3 divided by 1 is 3. Okay, and we have r squared divided by r squared. Okay, so we've got 2 r's up top that cancel out, and 2 r's down bottom that cancel out. Remember, anything divided by itself is 1. So our final solution will be 3. Okay, number 3, we have 3nm squared all over 4mn squared. Okay, so we've got 3 divided by 4 for our numbers. So we know 3 over 4 will be part of our solution. Now we have n over n squared. Okay, and I know when I subtract these, I'm going to get a negative number. Okay, I will have 1 minus 2, which will give me a negative exponent. And I don't really want to deal with negative exponents if I can avoid them. Okay, so I'll rewrite this as n over n times n. Just broke up this n squared to n times n. And now I can cancel out an n from the top and from the bottom. So I'm left with 1 over n. Okay, now for my m's, I've got m squared divided by m. So I'll do the same thing. I could subtract these two powers because I will get a positive number if I do that. Or you could rewrite it as m times m over m. Okay, so I could cancel out an m from both of these. So I'm left with 1m. Okay, so if we combine this answer, we've got 3 over 4 times 1 over n times m, which we can just rewrite as 3m over 4n. Okay, it might even help for you to draw your fraction bar right there and then start placing things in the top and bottom when appropriate, or where appropriate. Okay, so we've got m squared n cubed all over 3n squared. So for my numbers, we've got a 1 up top as our coefficient and a 3 down bottom. So 1/3 will be part of our answer. Looking at our m's, we've got 2 m's in the numerator and none in the denominator. So since we can't do anything with that, m squared will be a part of our answer. Okay, and then for our n's, we have 3 n's in our numerator and 2 in our denominator. So we could subtract these using the quotient of powers property, or we could rewrite it as n times n times n over n times n, and then cancel where appropriate. So we are left with just 1n. So when we combine this answer, we've got our fraction, okay? We know we're going to have a 3 in the denominator, and we're going to have m squared in the numerator and 1n in the numerator, sorry. So that would be our simplified version of this. Okay, looking at this one, we'll take care of our numbers first. So we've got a 4 in the numerator, a coefficient of 1 in the denominator. So that'll leave us with 4. Okay, so I'm already going to start making my solution for this one. Okay, so I can put a 4 in the numerator. I'll take care of my q's next. So I've got 1 q in the numerator and 3 q's in the denominator. So since that'll give me a negative number, I can rewrite it as q over q times q times q. These q's cancel. So I'm left with 1 over q2, which will be part of my solution. Okay, so I'll take this q2 and I'll put it in the denominator. So looking at my original problem, I've taken care of my numbers, I've taken care of my q's. So I've only got this one term that has a base of p and this one term that has a base of r. So they're just going to stay in the denominator. So we've got q squared, p squared, r to the fourth. Okay, pause the video if you need more time. Moving on to the last one. Alright, so I'll take a look at my numbers, or my coefficients. I've got 4 over 3. Since I can't simplify that, that'll stay a part of my answer. So I'm done with the 4, done with the 3. Looking at my x's, I've got 1x in the numerator, and I've got 3 in the denominator. So I'll rewrite that because I will get a negative number, or a negative exponent, if I subtract those. So I've got x over x times x times x. So we can cancel out an x on top and 1 down bottom. So we're left with 1 over x squared. So I can take that x squared and put it in the denominator. So done with our x's. We can take care of y's now, so we have 3 y's up top and 4 y's down bottom. I'll get a better visualization of this if I rewrite my y's like this and cancel out y's up top and down bottom. So I'm left with 1 over y. So that means I can put 1y in my denominator. And last but not least, we need to take care of the z's. So we have z to the third power over z squared, which is the same thing as z times z times z over z times z. Or I could just simply subtract the 2 powers. So I can cancel out my z's. So we are left with 1z in the numerator. So I will take that z and put it right next to this 4. So this would be our final solution. So pause the video if you need more time. At this time, I recommend moving on to the practice for quotient of powers.